Okay, you had a circuit. Some of you might find interesting. Discuss it a little bit. What it is a, well, oh shit, this is the wrong one. Okay, it's basically this circuit here. Okay, that's the circuit board to it, and this is what it is. It's a full duty cycle 555 square wave generator, and using this potentiometer and this potentiometer, it allows you to vary the duty cycle, from pretty much zero or close to zero to 100%, close to 100% at least. Um, it's kind of amazing this isn't in text. I mean, in data sheets, um, but yeah, I got it out of this, you know, same Hazen book. Um, which isn't that one. That's that's the one I had up. That's that little ramp generator, which I'm not covering. Um, it works, but anyway, it's uneventful. There's plenty of those out there. But basically, this is how it's presented in the Hazen book. And, Hazen, by the way, this is what the book looks like. You can find them used on like thrift books and places like that, even on Amazon for, you know, like $30 or less. But this Hazen guy like only produced like 4 textbooks, and then he stopped producing books altogether, like in '93. I guess he died or something. But it's a shame because this is the only textbook I've seen that actually has a shitload of useful circuits in it that you can actually build and that work. So most textbooks don't, like Molvino, for example. There's hardly anything worth building in there. But there are so many good, useful circuits in this that are just interesting. That's why almost all my circuits come from this textbook. But anyway, here's the actual built circuit. Um, so, you can kind of see. I mean, these circuit boards pretty much I build all myself, or made all myself. Um, a lot of them using that 3018 Pro over there, which you can see there. But it's done a pretty good little job, for a little circuit board maker, for sub $200 range. Um, but yeah, this the circuit does work. That's what it's doing right now. Right now I got it at 6 volts, and the frequency is 120 hertz. As you can see it right there, you can see I got a pretty low duty cycle on it right now. And of course, you can increase the frequency on a circuit like this directly just by upping the voltage, and it gives you some adjustment. This is a pretty low frequency, but the higher the voltage, got up to 8 volts now. It's 126 hertz and 9 volts, 127 hertz, 10 volts, 11 volts, 12 volts, 13 volts, 14 volts. You wouldn't want to go much above that. A lot of these are rated more than like 12 volts, but it's set at 9 volts right now. But you can see that like I said, you got 2 potentiometers on there, and by varying one versus the other, you can make adjustments. Of course, just like with any 555 circuit, anytime you adjust the frequency, the duty cycle changes. That's one of the things that sucks about a 555. That's why you're usually better off using a microprocessor, if you want to make some kind of a frequency source where you got independent control of the duty cycle. But anyway, if you're looking for something quick and dirty, this works. Now, I'm going to adjust this potentiometer, and you can see what happens to the duty cycle. And again, this thing's a little tricky to get the adjustments. It seems like the range changes with one pot depending on what your setting of the other one is. Like I said, I'm adjusting this like crazy, and now it's starting to adjust negative duty cycle range, which in effect is adjusting the positive duty cycle. So, the positive duty cycle is increasing. As I change this, you can see the frequency is also changing like crazy. But so now we're up to a pretty high duty cycle. Almost to where I need to change the scope, because the frequency has gone through the roof. Let me change the scope so you can see, we've gone from having a really, we've got a really low duty cycle right now, with the frequency has gone way the hell up. But now I can change the other pot. So again, just to show you the full range again, if I can get this stupid thing on here. See, that's what I'm saying. We're actually, in effect, decreasing the positive duty cycle as we do this. So, God, I hate trying to adjust these stupid little. There's got to be a better tool for this. This really sucks. Let's see, in effect, we've actually varied the duty cycle a hell of a lot. Just with this one potentiometer, just the same one that, I've been messing with here. So that's certainly, gone from a really low or high duty cycle down to a rather low duty cycle. But now if I start to, and that's about the limit of that one, now if I start to change the other one, I get even more range, adjustment. So we can go down to really small pulses here, vanishingly small in fact. So now I'll change the other pot again. If I can get this stupid fucking tool on it. Alright, so we got really narrow pulses, still, and, I'm changing, you can see how the frequency is changing. These pulses are getting quite narrow. And again, I'm still adjusting the same pot. The frequency's gotten quite high now with these little narrow pulses. Back it back off because I just hit the maximum range there. So I'll back it back off to about here. Now let me go to the other pot again. I'm trying to adjust this one now. I don't know if it's stupid tools on the thing. Probably isn't. Yeah, there it is. Damn it. Oh, this sucks. I really need to try to get some kind of better fucking tool for these stupid potentiometers. God knows doing the screwdriver really sucks. At any rate, like I said, it shows you, what you can do. You got to squirrel around with it, and that's one of the things that sucks about 555s is that you don't have independent frequency control versus duty cycle. So. But it does show you, this circuit does work. I mean, it's like I said, it's amazing. It's not in a data sheet anywhere. You only find it in obscure. I've never seen it on the internet. So, But yeah, you only find it. I'm adjusting the other pot now, but you only find it in obscure, obscure textbooks. So, but yeah, I'm just amazed. I've never seen this in the internet on any discussions or anything, but really don't look at a lot of 555 discussions. So it's probably out there somewhere, but anyway, but it does work, you know. But like I said, yeah, if you're wanting to, you know, that's one way of adjusting the frequency and stuff. But like I said, you can really, up the, change the voltage, and it does, give you a change in frequency too. So, that's another way of doing it. So, for example, you could, like, if you wanted independent frequency adjustment, at least over limited range, you could build a circuit like this with the 317 actually powering this circuit. So, like, the drawing over here, damn it, the drawing over here, like the 317 would power, this whole circuit, and you could set it, between a range, and you put a minimum limit like 4.75. This would limit it to about 6 volts, and you wouldn't want the maximum voltage being more than about 14 volts. But this is always going to drop 1.25 volts across it. You can have 1 to 10 milliamps flowing through this whole circuit. Then here's your potentiometer, that it allows you to adjust it from 6 volts up to 14 volts on the output. So you have to choose that. That's quite easily done. Here's your 555 circuit, and you can have the output going through a transistor switch like a 3904 with a suitable resistor here, allow like 1 milliamp of current flowing through it because you're just using it as a switch. So, but you can take your output and it'll be like fixed at between 0 and 12 volts this way. So no matter what voltage you had coming out here, it would still trigger this thing to act, and that way you could have some frequency adjustment based on voltage if you wanted to, while keeping your duty cycles basically intact. Let's see if they really change. You see, they don't really change that much, although they probably do change a little bit. It's hard to say, looking at the scope here without doing timing measurements. But the fact of the matter is that, that's one possibility. But, like if you're doing a PWM circuit, for example, you want to, you'd have to do a different arrangement. You wouldn't care about duty cycle with that. You just want a 555 circuit, and any 555 circuit will do it, because it'll generate a frequency. But when you change the frequency, the duty cycle always changes, period. Because you're really only adjusting one. That's what's nice about this circuit, is that it allows you to change both, so, because you got kind of a wave that does this and then goes down like that, but usually when you're adjusting the frequency, you're only adjusting like half that, you end up with something like, you end up with something like this, okay, across your capacitor, right, and you usually only have, and you're only able to adjust one of these, like the rise time or the fall time, but not both. This circuit allows you to adjust both, and that's why you got such control over the duty cycle. And like you saw, just adjusting this one potentiometer, I was able to go from pretty much very low duty cycle up to a very high duty cycle, just with this pot alone. And then this allows you to make further adjustments in between the two. You can kind of set a frequency, but it's like herding cats. But at any rate, like I said, normally 555 works like that, like this, where you only get so much adjustment over it because you're only controlling like half that waveform, and that's why you're adjusting the frequency. But as a consequence, you also adjust the duty cycle. So like you'd have to take like a so like a regular 555 circuit here, and powered by your VCC or whatever it is, and you have a pot, all right, to adjust the frequency, Alright, and you take that, but because the duty cycle varies, you couldn't use that for PWM, but you use this to set your frequency, like 1 kilohertz or whatever you want your PWM frequency to be. And then you have that feed into another, 555 that's basically a one shot. So, and it's triggered based on, the output of this. So this fixes the frequency, but this fixes the duty factor. So you vary this, all right, to get you the duty cycle. And you take that output and, send it, probably directly, honestly, if you got the voltages right to your, servo motor or whatever you're trying to control with it. So, this allows you to actually control the servo motor, but this keeps the frequency fixed. So you got, in fact, PWM. So, which by definition, PWM, its frequency doesn't change. But at any rate, that just kind of, that's kind of a pain in the butt to do that. You got to use two 555s to do it, but no 555 circuit can you adjust the duty cycle, including this one, without changing the frequency. It's just how it works, pretty much. So, but again, that's why you're better off with like one of those little 8-pin microcontrollers. So, like a PIC or something like that. A lot of those are 4 megahertz. So, so if you're running 1 kilohertz PWM frequency, you could, maybe, especially if you're doing it in assembly language, you might have 1,000 steps of resolution on it. Anywhere from 1 kilohertz up to 1 megahertz, because you got instructions that have got to operate at the very least. And if it's a one cycle instruction chip, like a Atmel or something, you might be able to execute 4 instructions, per pulse max, so you can get, pulse widths that vary from, like I said, 1 to 1,000 of your target anyway, depending on what your target is. So, it just makes more sense typically to do it that way than with a 555, unless you just don't like programming. But again, you could probably do it in C if you don't need 1,000 steps of resolution. But I'm just saying, because of digital and how it works, you're either going to get, again, if this is your maximum pulse width, and let's assume that was 100%, you'd never drive a servo, of course, at 100% pulse width, but but it would allow you, steps of 1/1000th, of, like 1 microsecond resolution steps, between 1 millisecond and, on up. So you would you could generate it at that kind of resolution if you wanted, so you can have 1,000 different points, like that. Or if you ran it at a lower frequency, you can even get more points, and maybe write it in C++. But my point is that if you're wanting to do PWM with 555, they are a little squirrely, but because you don't have that frequency kept constant. So it's just how it is. So but anyway, it's a neat little circuit, and it's, like I said, surprising. You just don't see this in data books as far as I know. So anyway, I just wanted to let you know about that. Cheers.